error, it's going to do that by essentially inside itself doing *E, go to that structure, filling it with an error code, filling it with an error message, so that effectively this is passing back more than just nil in the case of an error. Okay, so in short, this is the second way we can pass errors back and forth. Yeah?
Where does the allocation take place?
Where does the what take place?
The allocation of the NS error.
So in this case, it would, actually, that's a good question here. Does it handle it itself? I believe, let me double check. I think the convention with some functions is actually to allocate it for you, but because this was deliberate that I initialized this to nil, but let me double check on that just to be safe. Yeah. Other questions? Okay. All right. And that's it for Objective-C. All right, so hopefully we have a lot of the building blocks. The syntax you'll get more comfortable with, and we'll start seeing it quite a bit. But now we can move on to iOS itself, iPhone programming. But any questions? All right, so thankfully, the stuff we're about to start talking about is actually quite familiar. At least it's familiar if you wrapped your mind around it the first time around, in the context of CodeIgniter and PHP. So in MVC, you again have models, views, and controllers. And in an English sentence, what's a controller? What does it do? Yeah? Okay, so it allows the models to communicate with the views. I would tweak that a little bit in that it allows you to take data from the model and pass it to the views. It should really remain the middleman. But sure, and more generally, it controls really the whole logic of your program. What is a model meant to do? To find data. So the model talks to your database, or it represents some real-world entity, like a student model could represent a student, or a student's model could represent a whole collection of students in a database. And how about the view? Yeah.
Presents all the data to the user.
Yeah, it has to do with presentation. And so what's nice actually in the world of iOS is that once Apple released the iPad, people didn't have to go out and rewrite the entirety of their applications if they wanted to then port the same code base to the iPad, whose screen resolution was bigger, the screen itself is physically bigger. You can simply implement some additional views that maybe have more on the screen or at least blow it up. But it was relatively easy to make that kind of transition, and will continue to be so, especially if the iPad 3 or whatnot has even higher resolution and the like. You can simply have different views for different hardware. Same thing can be possible with Java in the Android world. So we're about to start making heavy use of UIKit. So this is just another library from Apple, similar in spirit to the foundation classes. UIKit refers to user interface mechanisms. And the buzzwords, or the classes we're about to get quite familiar with, are UI application, which is a class that represents an iOS application. UI application delegate, which really represents the brains behind a iOS application. It's to whom you delegate control of the application, as we shall see. A UI view is just a view. It is a very generic class that represents the notion of a presentation layer. And so when we see things like buttons and text fields and the like, turns out those are going to be descendants of a more generic class called UI view. So a UI view has something to do with aesthetics and presentation. So all the little user interface widgets with which you're familiar on your smartphone are going to descend typically from that class. UI view controller. Now this is where Apple jargon gets a little confusing. A UI view controller is a controller. What it's controlling is views, which is not all that different from the conversations we've had thus far, but it's not a view. They just call it view controller, and it would be nice, frankly, if they just called it UI controller. But it's UI view controller. But it's just a controller. Okay, and a UI window is actually itself a special case, as we'll see, of a UI view. So the UI window essentially refers to a class that represents the rectangle that is the screen on an iPhone or an iPad. Inside of the UI window, you can have multiple UI views, little rectangular areas like divs in HTML, or UI buttons or text fields. So there's going to be this whole hierarchy also. And this is where object-oriented programming is again useful. We can have these hierarchies of inheritance so that you can divide this rectangle into little parts, each of which itself is some kind of view, a specific type of view. All right. And templates. So as we saw terribly briefly in the past when I made the stupidest of iOS applications and called it an app by just writing hello world or the like, that was expedited because the Xcode comes with these templates. We could start with a completely blank .m file, completely blank .h file, but frankly it would take like 20, 30 minutes to actually configure all of the various settings in the IDE, to talk to the compiler, to talk to the simulator, and actually get the beginnings of a hello world application going. So you almost always in iOS just start with one of the templates. Maybe the minimalist template, maybe the maximal template, and then you start ripping things out and adding to it. So just realize that these templates are not themselves doing anything magical. It's just someone at Apple spent the time wiring things up, writing some often poorly commented sample code that they then called a template just to make some things easier. But realize that, again, stylistically, they're frankly a little bit of a mess. White space, indentation's not always correct or not always consistent. But realize you can do anything in iOS from the bare bones template. It just might take you more work. So just realize those exist. And then lastly this summer, in addition to automatic memory management, automatic reference counting coming around, which again we'll talk about in a couple weeks, Apple introduced the notion of storyboards. This is meant to make easier the process of putting together an app, because many, not all, iOS apps have like screens where you touch a button and the thing scrolls to the right. Touch another button, it scrolls to the right, or something like that. So not Angry Birds, but more of a data-driven application. And so storyboards are meant to facilitate that type of application where you touch something, you see new content. Touch something, you see new content. Not so much graphical, but a standard UI mechanism with like a little scrolling view or buttons or scroll bars or the like. So storyboards allow you to really paint a picture like this on what looks like graph paper in the user interface, where you can drag and drop these things, and then these arrows that are a little faint on the overhead in gray represent segues or transitions, whereby you define what should happen when the user transitions from left to right, and then further to the right, and so forth. Storyboards do not enable any fundamentally new functionality. They're just meant to make things easier. They're a little complex. In fact, the template that Apple ships that includes storyboards, the templates, are frankly a little complex. So we'll start today with nib files, simpler user eye mechanisms, but this is just a layer on top of what we're going to keep calling nibs, little user interface widgets that make it easier to program things. All right, so that's it for jargon and sort of exposure to broad concepts. We can now dive into some code if you'd like. All right, and so this is a bit of an anomaly. This week, I actually printed out handouts simply because there's a lot of code and a lot of new syntax. So do feel free to either follow along on your laptop, the code's online, or to actually follow along here. And this is definitely the sort of thing whereby if you get lost, you kind of then lose track of the rest of the conversation for a while. So please interject at any point with questions, confusion, and the like, and feel free to grab some handouts if you didn't yet grab them. All right, so the first file I'd like to turn our attention to is called student7. So there were a couple of, remember we had this series of student-related files, and let's just round out that conversation by adding a couple of new functionality, a little bit more functionality that lets us solve problems, as we'll see, in different ways. So let's look first here at student.h. So this is student7, student.h. And this file simply looks like this. So recall that a student last week descends from NSObject, for the moment has no instance variables, apparently, and there's nothing in the curly braces, but it does have two properties, a property called age and a property called name. So just as a refresher, since we have to start taking this jargon for granted soon, what is a property in Objective-C? What's a property? Give me any recollection you have of this word at all.
Variable belongs to a class.
Okay, a variable that what?
Variable that's part of a class.
Okay, it's a variable that's part of a class, but it's not quite an instance variable per se, but there is often this one-to-one mapping. So a property, yep, Charles.
Well, it'll create the getters and setters for it.
Okay, good. So if you declare a property for a class, as I did for age and name, this enables you subsequently to use the special keyword at synthesize, which, recall, just saves us, frankly, a lot of work. It synthesizes. It automatically creates for you, thanks to the compiler's cooperation, what types of methods? Getters and setters, right? Unlike the world of Java, where you copy-paste ad nauseum to create getters and setters, Objective-C can do this for you automatically. It also, a property, gives you some syntactic sugar. What does declaring a property also let you do? It lets you use, yeah, dot notation. So instead of having to write something like if S is a student object and I want to get S's age, typically I would do this. And this would return to me the value of the age method. Well, or if it's actually an instance variable, I could do this, which we've done in C, which we did at the beginning of last week's lecture. You know, both of these are fine. This is direct access. This is a message access. But this, frankly, is just a little ugly, especially if you start nesting things. So this can be simplified to just s.age, where the only difference now between s.age and s arrow age is that, again, this is direct access, but this is actually invoking what? The getter. And that's useful because the getter might do a little more than just return the raw value. It might return 0 if it's just undefined. It might just behave a little bit differently. So that's useful. But more useful, too, is that if you also say something like the other syntax we saw a bit was s and then set age. Recall that the convention for setters, by human convention, is the word set in lowercase, followed by the variable name in uppercase. And so the convention here was to say set age, let's say 21. This now gets simplified to what syntax? Thanks to properties. This is not, now we're blocking you people. What does this get simplified now to? Exactly. S.age gets 21. And now properties are getting more compelling, frankly. Syntactically, now this is actually useful. So properties are used throughout the iOS framework. It's a good habit to get into. You still need instance variables to store the data, but you don't need to declare it explicitly because when you call synthesize, what can you do? You can do this little trick. You tell the compiler, synthesize this property. In other words, generate for me, getter and setter, but back that property with this named instance variable, underscore age and underscore name. Now this too is a convention. It is perfectly legitimate to just do this. Synthesize age, synthesize name without the equal sign. And take a guess. What do you think the instance variable will be for each of those that's automatically generated by synthesize? It's just age and name. So that's pretty good. But the difference here is just, again, a human convention. Often, if you want something to effectively be private, there's this convention of using the underscore so that it's not conflated with methods, which are typically named without such underscores, at least in iOS. All right, so this is Apple convention. So for the most part, if you look through Apple's templates, you can pretty much infer what conventions they want the world to adhere to. And frankly, it's a moving target. The templates themselves have changed over time, and Apple's own style has been evolving. So it's fine to pick your own, but probably best as a starting point, just go with what Apple recommends. So your code will look like the rest of the world's. All right, so now in the .h file, we had just one other thing besides properties. We had a declaration of an initialization method. This too is a common paradigm in iOS. You typically get an init method, even if you don't define it. Where is the init method actually defined? In the NSObject class. But it's convention also to have init with foo, init with bar, if upon initializing the object, you want to pass in some value or even some values. So in this case, I decided, you know what, for a student, rather than have to instantiate the object with alloc, then call the generic init, then call two setters to set name and age, let me do this all at once. Let me have an init with name, and that takes a name variable, and age, and an age variable. And now I can set both of those things at the object's initialization. I have to implement that thing myself. So in the .m file, recall that we did this. Below the synthesis of those properties, we had a declaration of init. Now I'm overriding the NSObject class's initialization, just because I decided that I want John Harvard and his age to be the default for any student object. Just because. I didn't need the init declaration in my .h file, though. Why? Why did I not need to declare this init method that I'm implementing in the .m in my .h, even though I could have? What's that? Inherited. Same answer as before. It's because NSObject.h already did that for me. So you can do it, but it's not necessary. So in this case here, notice the convention. Self is like this in PHP and Java and some other languages. And notice the convention in iOS 5, older textbooks and older templates don't do this, is to make sure that when you call your initialization method, you reassign it to self. So update myself to be the result of calling init with a name and age, and then return self. And this is, again, an initialization method. Ultimately, it's got to return itself, but it can do some preliminary changes to it like this. Now, init with name, same idea, but it's a little more explicit. So here, the convention in any init method that descends from the NSObject class is to call super inits. And for those familiar or just a guess, who does super refer to? The parent class. So in this case, call the NSObject class's init method. I don't know what it does, and secretly it doesn't do anything, but Apple makes no promises that it's not always going to do nothing. So you better call it as a matter of best practice.